I'll just get started. So we started off in the morning with the first group of SMEs that talked about all their experience and at the practical level, what they actually did. Now we're going to talk, that was more about modeling and simulation services and such. Keep on going. Now we're going to get into another cool part, which is about lasers in manufacturing. Now, I am quite interested to hear about this because I'm a bit of a Star Wars fan. Did you actually know that there's going to be a next Star Wars follow-up movie at the end of this year? Sort of a Star Wars 7. And they've actually changed the lightsabers, you know, that it's two-sided now. So from a laser perspective, that should be pretty cool. But we're going to talk about other insights today. And to kick it off, we have Ulrich Tombansen from the Fraunhofer Institute. And he's with the Institute of Laser Technology. They provide solutions and services in the field of process control and system technology and such. And he coordinates the LA Share project, aimed at establishing accelerated laser technology transfer by means of conducting laser-based equipment assessments. Now, I am curious to hear if that's a risky business or not, but I leave the floor to you. Thank you.
It is a challenging business, because one of the things that are special about this laser equipment is that in most cases you do not see the laser. There are some green lasers out there, those you can see, but most of them are in the infrared, so you do not see the tool that you're working with. But still, if you look at all this setting, all this environment, would you think that laser is involved in that one? It's not directly contributing to it, but the molding tool that does this injection molding process for the plastics, that one is extremely enhanced by drilling micro holes for ventilation. So as soon as you push in the warm plastics into that form, it can go in much faster when you drill holes into the form. A solution is developed within LaShare that enables this technology to be used, so that we're talking about an enhancement in production speed of more than 70%. There's another application area that's microstructuring, so you can change the property of surfaces. That's done with these nice things. That's a replication process. So you change the surface of a die and you press coins with it. So you have completely new features on these coins, and Clemens is going to talk a little bit more later on about this project. Lasers can also be used for creating shapes. So here, for example, we're talking about thin film processing. So you have a plastic substrate, you put some metal on top, and you change the properties of that metal to give you a shape. We're talking about using of ultra-short pulse lasers, which are pretty much expensive. If you split the beam into multiple beams, like you see on the bottom left, with these 4 parallel processing steps, the equipment that you need for it is on the top right. So this is this kind of structured diffractive optical element. Then you have 4 beams at the same time. So it can change from processing speed of 1 to processing speed of 144 if you use 12 by 12. So that are the challenges, that are the changes. Another thing you might have heard about is 3D printing. So you can create today products that have internal structures that you cannot manufacture by any other process. That's going into serious production for GE in fuel nozzles. We talk about protective coating. So you blow in powder, you heat it with the laser so that it sticks to the surface of something. You have a big problem if you try to do that for an inside tube. So what's being developed is a very, very long optical system that provides this coating technology to a tube of a diameter of 50 millimeters and 1.5 meters long. So those are technologies that are samples of industrial applications that serve a wide market and that might even be exploited to other areas. And that is the focus that the currently implemented laser projects in I4MS are for. Looking at the market, laser equipment, the rise is quite immense. We're talking about, it depends on who you ask, but most of them agree that we are somewhere between 5 and 8% of growth. and that is a sustainable market growth. There are coming out new applications every day, like, as I just showed you, thin film processing as new performances with ultra-short pulse lasers, which enable new technologies, and the changes are quite significant in that area. The first project in this row is the Apollo project. They have set up their concept of being a hub of application labs. So they have 5 laboratories, 7 users, 7 suppliers, and they focus mainly on microprocessing. So that's thin film processing, surface texturing, and patterning. The other project is La Chair, and in La Chair we try to implement from the base of having joined 6 renowned research partners to a La Chair Competence Center to provide something what we try to call assessment circle, an assessment methodology. So to look at the equipment, to look at its transfer to production and the requirements that it needs to go from a lab demonstration to a robust prototype. How does I4MS now help? From our perspective, from what we see today, is that this communication between user that is going to represent the market, the supplier who has got an idea but does not have access to industrial application, and the research partner, if these 3 sit together and really jointly try to develop and to put forward a new solution, that this, with the backup of the scientific stuff, really leads to an accelerated technology transfer. So when they agree on challenges and solutions, they have measures in force to validate the achievements. This lowers risks and barriers. So that's what we were talking about, to lower the entry risk of suppliers to enter a new market, to bring out a new equipment. This lowers the risk of the user to buy a new equipment, to introduce it into its company. And so that helps both sides. What we see today is that there are already revenue streams from the publicity that the SMEs gain from that they have already requests for new products, so they already add stuff to their companies, and that they currently start to focus on their exploitation and even on extension to new application areas. So how are we going to take it forward? You all heard about the competitive calls. Apollo has, at the change time of this September, because we are a little bit behind the timing of the other projects as we started in September 2013. So in September, we will have 8 validated applications for Apollo, and Apollo will implement 6 to 8 new applications in their framework. Le Chair will have 14 assessments finished off, and we'll try to implement 12 to 14 new LEAs at that time. And we're going to have a new event at Laser World of Photonics, where we try to talk to all the participants of the market, so to the users and to the supplier side, and to present what's currently going on in the I4MS funded projects, but also in the other projects. So also this brings together the value chain of the users, the suppliers, and the helping or assisting research partners. So that's all I wanted to talk to you at this moment, and I would like to hand that back to Dinant to introduce the speakers that are going to be a bit more in detail and a bit more specific, and also provide some figures to you. Thanks very much.
So the expectations after this morning are quite high, given the diversity. And the first speaker I want to invite up is Jordi Garcia from Monocom.
Okay, once I was told that when you are presenting something, you got a KISS. KISS stands for keep it short and simple. So today I will try to KISS. Unfortunately, I'm not Jordi Garcia. today. Jordi Garcia is our R&D director in our company. Some of you know him, and he has recently become father, and that's why he cannot attend today this meeting. So I'm Carlos Uriac, the sales director of the company, and I will replace him, just because Jordi, at this moment, is dealing with something that is probably more important than this. Sorry about this, but that's the truth. In fact, when you become father or mother, your awareness of risk starts to improve a little bit. So you start doing so many things, and one of them ends up buying a safer car more normally, bigger and safer. And that's what we are doing here in this project, in fact. Because in order to increase safety in cars, you need safer parts, more robust parts. In fact, one of the main components of cars is the steel, and you most probably know about it. So if you want to increase the safety of a car, you need a harder steel. But you, at the same time, need to work with it, shape it, deliver it to the exact form factor you need. And one of the drawbacks when you play with this hard steel or higher strength steel is that although it's harder for resisting impacts, it's also harder for working with it. You cannot bend it easily. And things that do not bend eventually just break. And it's what normally happens when you try to roll form a steel. We have a short video. Well, in fact, it's not that short. It's a 2-minute video, but we'll try to keep it shorter, showing you how steel is normally formed. And you have these big rolls where the steel stripe goes by, and it's starting to get bended gradually. So this is the main point. But as I was telling you, when this is done at a cold temperature, this steel will break. If you try to heat up all the sample, the whole sample, in order to help this bending process, you change the material properties. And changing the material properties means that you will lose some strength of this material. And if you try to heat it locally, but slowly, like is the current techniques right now, you don't achieve the degree of the performance that you will need. So what can you do here? And what we did, in fact. Sorry about that. I just clicked on the same position of the slide. Here. We developed a laser, a diode laser, that is directly applying on the sheet, the metal sheet, as when it is really working. So this should be like a normal roll forming station. And here you have a picture of the laser that is heating up locally the zone. So what you achieve is a very fast temperature raise in a very small area of the steel that helps you bend it. So you can start working with this steel that up to now it was just impossible to work with. So we did it with a new development thanks to the technology that Monochrome has, that it has some advantages. Monochrome is the company I work with. And we have a that is capable of delivering laser bars with no smile. That picture you see on the upper right side of the slide, where we are comparing a normal laser bar versus a clamped laser bar mounted with our technique. So as you can see, this is completely flat. And when this bar is completely flat, you can do things like this one in the lower part of the slide, combining lots of these high-power lasers in order to achieve extremely nice beam profile, very nice line in the metal sheet. So you can work exactly on the area you need. So this was bringing our technology to a new application field for us. Monochrome is an SME based in Barcelona. We are only 35 people working high-power laser diodes, and we are mainly working in the medical field. Okay, we have some applications also in space, but we are mainly working in the medical field. So we had no experience in material processing at all, nothing. And of course, we didn't know anything about the potential market of it. In fact, we normally thought that laser diodes are not really useful for material processing. Other kinds of lasers are normally used for material processing, not ours. So what LaSure bring to us, what FLIT bring to us, is the opportunity of start working in a new field of applications that in fact is huge. I mean, our annual turnover is like 3 million euros. The impact that this project can have for Monochrome is about 10 million euros. So just imagine, for a small company with no access to big customers, with no access to this market, with its mass-consuming market of like the car industry, can this kind of project represent? So this was really helpful, because the component manufacturer don't usually know how his technology can work in a different environment. And in fact, we just discovered that the power level you need for metal tempering is just the same that you need for hair removal, so which is one of our main strengths. And it's surprising, but right now it opened a huge new field of applications for us. How did it come? Well, our partners in this project know what do they need, roll-forming metal sheets, high-strength metal sheets. Another partner knows how to do it. What do we need? What parameters are required in order to do so? And they already know that we existed, luckily. So that's how we joined it with our technology, this project. So really, the scheme, this financial scheme is really helpful. And I think that the main message that I should be telling to you is that, yeah, maybe I am not keeping this presentation really really short and simple, but LaSure was a real kiss for Monochrome. I mean, it improved ourselves. It made us learn new skills that we will apply in the future, and we are still not ended with this project, because right now we are learning what the big industry wants. So now we are integrating new signaling in this laser head. Now we know what kind of interfaces do they normally need. Now we can explore other material applications that we even did not know before joining this project. So the main idea I would like to bring today here is that these kind of schemes work. These kind of schemes help small companies to access big markets, to have more knowledge, to hire new people, and in fact, in places like Spain, 70% of our GDP comes from SMEs. So please, keep supporting SMEs, because for a country like ours, with this kind of economical situation we have right now, these kind of things can make a real change. Thank you very much.
Thank you, Carlos, and also thank you for taking over for Jordi, who's now who has just become father. Next presentation is Andreas Mikhailovas, and he's the science director of EXPLA, manufacturer of lasers, laser systems, and laser components. So I think the next episode of Star Wars is for you.
Thank you. Good day, everyone. I'll starting presenting another one project, Apollo project. As was mentioned, it's a project in which scientific labs assessed laser equipment for certain kind of the technologies. And what we achieved in this project is, as for you, for non-laser people, our achievement with a picosecond laser with 1,342 nanometer wavelengths sounds quite curious and not very interesting, but for people who are involved in semiconductor technology, this wavelength it's very attractive, because silicon is transparent for this wavelength. And there is a lot of possibilities to machine silicon wafers from all sides. It's just introduction. And For audience, is not very interesting what is inside this box. For laser people, it's more interesting what is outside of this box, and we succeeded to make a quite powerful laser, which is attractive for using keys in laser technology. With quite high repetition rate, which could assure good manufacturing speed, and a lot of control regimes was realized in this laser. And one of the challenges was to make synchronization with quite modern devices like polygon scanners. About development of these scanners, the next presenter of our project will tell for you. But as this laser was very interesting for semiconductor technology. The validation was done on the semiconductors which were used in thin film photovoltaics batteries. The job is just started, is not final result yet, so I will not inform you about something with very brilliant results, but there is some information that it could be really attractive. And if laser people took this big toy in their hands, they start to experiment far. Not only with this particular wavelengths, we started to tune this wavelengths in different spectral ranges and got colored radiation from this laser too. How we did it. Many years ago, we got a custom order for making one 342 nanometer laser, and we have done. And after finishing the project, we realized that there is a lot of things we will, in future, will do in different way. But as there was no any positive signs from the market that this kind of the laser is desired, so we were not proceeded with this wavelength. And when Apollo project started and the request for this particular wavelength was come to our company, we realized all this, our previous experience in this laser. And for sure, it was quite challenging work because it is not standard wavelengths. There is a challenge with components, there is challenge with suppliers, and it is a challenge with controlling. And just to show you how looks big laser outside this illustration. It is a lot of components you see on these optical tables. We succeeded to put in this small box, which I have showed you previously. So there was a lot of engineering and a lot of experimenting. And as I mentioned, despite that we have previously experience in making this specific kind of lasers, we will never proceed with developing this kind of laser without external financial support. There is another very attractive side of this kind of the projects. If we are speaking about application of the lasers in the industrial environment, we are speaking about robustness and working 24 hours, 7 days per week. And if you are developing new device and put it to the customer, there is very big probability that laser fails. And when you are, give the laser to scientific lab and laser fails, you'll have feedback and time to develop this laser, sorry, till it will be operating properly. So this very nice pool of the research labs and potential customers with reducing risk of the failing, it's very attractive. And really, outcomes is new markets. It's very funny, but project is still running, but we have 2 serious requests from the semiconductor industry. It is about how we will take it further. And another aspect we realized during performing this project that it is very difficult to do the job in the same space as using production. So through taking part in Apollo, we were forced to equip new R&D facilities with new clean rooms. We started our new mechanical shop. We have bought new test equipment because non-standard wavelengths is a challenge not only for optics but for control equipment too. And our predictions, we are not Nostradamus. No, Nostradamus is not our collaborator, but we are seeing our tendencies, our tendencies that we are growing steadily, and in every 5 years we are doubling our turnover. So we can predict that Apollo will support us too in keeping this tendency and in growing our sales in future. Thank you very much.
Thank you, Andreas. So going from this example, lasers in, I can only summarize it as lasers in boxes that do fancy stuff. Now to move to large painting from NextScan. And NextScan, how do I describe it here? Lots of details, but to enable the performance of next generation laser sources by doing a whole bunch of stuff. And actually, what I did find out is that you just apparently returned from living in Korea for a while. Yes. So it's actually interesting to see your reflections from hearing the stuff today. Anything that strikes you so far of what the Koreans do differently in a positive or a negative way? But again, that's something you can build on.
Okay, well, to start, they are quite fast in developing all kinds of new technology. So that was quite an impressive experience over there. But I can tell, I think, more than 10 minutes about South Korea. So let's focus on this one first, and then we can answer some questions otherwise. Let's see. Because... Okay. I'm used to a mouse or something like that.
I thought you were going to say you're used to a Korean keyboard. But should probably be over here. And then, which one's yours? NST.
Let's take that one, yeah. Sorry about that.
There you go. Yeah. You probably put it full screen.
A full screen view for...
French keyboard as well, you know, difficult things.
Okay, well, we can skip this one. The outline is well known, I think, after a few of those presentations. Let me start with NextScan technology itself. I'm the co-founder of the company. We started 5 years ago as a startup. We're into enabling the new type of lasers. Almost Star Wars, but not exactly yet. However, there are some interesting things going on, especially. What we do is we develop and market laser scanners, and not the laser scanners you use on your desktop, but laser scanners you use for removing material or changing of surface properties, just like Mr. Uri explained a moment ago. Let's see. What kind of opportunities we unlocked until now? Like I said, the interesting part is that there's a lot of consumer electronics being manufactured at the moment and in the future, of course, which requires all kinds of laser processing because features are getting smaller and then mechanical tooling isn't very useful anymore. So that is what we have unlocked in the last few years. That was also the reason for being in South Korea, because I think that's the one of the key markets where things happen. If we put that into perspective of potential impact, so what we achieved and future impact, we already were able to hire some new people because of the interest which we have gained from the marketplace, and expect to hire more people than that. Also, the interesting part is that the features which we are developing in the Apollo project are required by mass volume marketplace. So that will definitely unlock a new opportunity. And now that one. Okay, how do we did it? Although we are only 5 years young, old, depends on how you define it. We have a long-standing track record in the graphic arts, which is more or less the genesis of our company. So we're transferring that technology into laser material processing. So I think we've done quite good because that gave us a head start to other companies, and achieved to also challenge some of the European suppliers, because we needed new components, optical components, which were not really standard in the field of laser material processing. So I think we achieved some interesting results, which will benefit future applications. But most important thing is, of course, that as a consortium, which Apollo is that we were able to collect all kinds of requirements which were necessary to develop the product itself. So together with the business case presented by the consortium, we also discussed this, of course, with potential customers, end customers. And just to give an example on the future potential, like I said, Northeast Asia is a key marketplace for consumer electronics, and that means smartphones, tablets, PCs, and large area flat panel displays, television sets, which are now getting quite popular, the big ones, because they get all kinds of interesting features. And to give an idea about what the mass volume production capacity is there in that area, I have to change that, because yesterday I read it's 261 million units this year only. So that's quite some football fields of electronics which need to be processed by laser. But another topic is, of course, the solid state memories, which are being produced on wafers. I think we all seen the pictures of round products which require all kinds of features again. Now also South Korea is a marketplace which is quite present on that volume. So how 4MS helps, of course. Let's start with the funding. That's especially as a startup company, there's always lack of funding. So that was enabling to build a demonstrator to show proof of concept to the marketplace, and also for customer interaction, because we all know that if you develop a product, it's never the one the customer wants to have. They always want the green, yellow, or black, or something else. So anyway, this gave us the opportunity to interact. Additionally, of course, by having funding, yeah, it is also more interesting to get into discussion with the banks, with finances, because that also gives some trust that you have some future liquidity and yeah, being able to grow the business. But also, yeah, I think the one which is most important is to enable an head start in the competitive marketplace we are all in. So from that perspective, yeah, again, thank you for the possibility, because this is really really important for small companies like ours. Oh, that was too fast. This one. So how will we take it forward? Just recently we built a new facility, and to support the growth. So we were quite small located, or quite small facilitated. So this will give us the opportunity to support more space for engineers, but also for production and our application lab, which is a concept which we are now yeah, copying into the Asian marketplace, again because of the potential market opportunities over there. So I think that is it's not that far from here, near Ghent. So I think that will be a nice hub for the future and for some successful business, I think. And now the last one. Thank you for the opportunity.
Thank you very much. We'll save the Q&A again until just before lunch, and then we can combine the questions from both the laser side as well as the robotic side. So next presentation is, the introduction to the next series of presentation is from Bruno Siciliano. No. Did I forget one?
Yeah, still one. Still one, yeah.
Ah, I apologize. We have one more laser. Very good. Clemens Hunninger from Amplitude Systems, correct?
Yes.
Okay, thank you very much.
Thank you very much. Yeah, so our laser pulses are so short, maybe that was a problem. Is this the right presentation? Hopefully. Okay, so I will, let's first introduce a little bit. My name is Clemens Hunninger, as speaker already talked, and I'm coming from Amplitude Systems, an innovative SME in south of France, southwest of France. What we did in the FEMPA project part of the La Chair project is we had a challenge to produce embossing tools for stamping money. So basically the project was, or the sub-part of this project, the laser assessment was about making money for making money at the end. Okay. So we do 3D laser ablation to generate these embossing tools, and these embossing tools will use to stamp coins, as Ulrich already introduced in his part. Key issues were quality, to get really high quality and reproducibility of these stamps in order to reproduce the money coins, and the processing speed. This is always the key challenge in industries. High throughput has to be attained. Currently, for example, kind of this making of these embossing tools takes more than 10 hours, and also in terms of differentiation, it has some limitations. For example, only 3 shades of gray can be realized with these coins. I think everybody knows it's just the money coins that we have, everybody in our pockets. The laser that is used currently at La Monnaie de Paris is the nanosecond laser, and well, we wanted to do some innovation here. Innovation was to go significantly down in pulse duration to the femtosecond level. This is very, very short pulses, 6 orders of magnitude lower than, or 5 orders of magnitude lower as the 12 nanosecond pulses that we are talking about here as a state of the art. and giving some innovative features, as you will see in the following. So the innovation was to achieve a new quality of 3D engraving and 3D shaping. That means we want to reduce the step effects when ablating with laser pulses metal focus by focus or pulse by pulse. You typically have some kind of a digital effect, and we want to smooth out this effect by doing very precise machining. And this can be done with femtosecond pulses. And you see on the upper right part, for example, the measurement of the structures that have been produced by the project partner I4MS. It's very smooth structures, very low roughness, very good roughness can be obtained. And we also attained an objective in terms of the production speed. So we almost increased the production speed that was today possible by almost a factor of 10. And one other very important thing is by this innovation we could create new features. So the laser together with the end user and especially together with the process developing partner I4MS developed new features. Holographic effects can be produced on coins now that can be embossed. Holographic effects means that the structures are really on the order of the wavelength of the light, and you can produce with this interference effect different colors, as Ulrich has shown, for example, in one of his slides in the introduction. And the quality was excellent, and also the reproducibility of the coins was excellent with this method. One enabler of this was the laser source development. That was our part in the laser equipment assessment. We developed a high power, high energy femtosecond laser with 50 watts of average power and 40 microjoules of pulse energy. This is world-leading parameters for femtosecond lasers today. The pulses were shorter than 300 femtoseconds. This is about a factor of 3 lower than what is typically on the market today, and everything up to megahertz repetition rates. And here there might be some cross-relation with the talk that we just heard from Lars. The next scanning technologies are very adapted for these high pulse repetition rates, for example. Okay, so we have obtained quite high stability and robustness of this laser source, put it into an industrial packaging prototype, and could test this laser in a production-like assessment at partner I4MS. This slide just shows the comparison of the state of the art on the left side and the new results with a femtosecond laser on the right side. It's clearly seen that we have the quality advantage, and we also have a speed advantage. See on the left side with the nanosecond process, we have higher roughness, and it takes 40 minutes to do only this kind of shape. And with the femtosecond laser, it takes 5 minutes. This is only a part of the coin, for sure. It's not the whole coin that only takes 5 minutes. Okay, how the I4MS institution helped. So that was to put together the end user, find some player who had a requirement, the laser supplier, and a competent partner for research to generate and develop the process that was necessary, and maybe even new processes, new innovations in these aspects. So all these partners could team up. Monet de Paris is a very old institution in France, I think founded before the year 1000, and still innovative. Amplitude is a teenager today. We are 13, 14 years old and still dynamic. And I4MS is the research partner. We have a very good collaboration, and resources and knowledge could interfere in a very constructive way. And the solution that we developed have been validated in a production-like environment. In terms of the impact, how we will take these results forwards, the laser development and the sales, we have released a new product based on this project results this year. These are alpha and beta prototypes. First laser sales have been are in the pipeline, and new markets and opportunities can be addressed with the results of this Lacher project. And in terms of the application development, the femtosecond laser technology and the femtosecond laser processing, which gives new differentiating features, can be introduced at Monet de Paris, and together with the Alphanov Competence Center, continued process development for these 3D processing and other applications can be put forward. To conclude, we already heard, so embossing tools to make money for making money is one aspect of this project, or was the aspect of this year, but clearly there are other opportunities on new markets as well for the laser sources. For example, femtosecond lasers are very well suited for processing of multi-material products, and the development of sophisticated product that needs extremely high precision. For example, medical devices that will later be incorporated in the human core. Or consumer electronics products, injection nozzles for drilling for automotive industry, lighting applications, and so on. And the continuous challenges are operation in industrial environment, and there this project gave a nice opportunity to check this, and further tendency for high power laser development for high throughput. Thank you very much for your attention.
Thank you, Clemens, and apologies for forgetting you initially there in the laser section. Actually, kind of cool. I learned something new. Femtosecond laser technology. I'd never heard of that one before, but it is kind of valuable to see how something like that can take an old institution like the Monet, the Institute of Money in France, to go from coins with only 3 shades of gray to maybe even coins with 50 shades of gray, which can be useful for the French economy. So. Now moving away from lasers to robotics, next introduction will be by Bruno Siciliano, Professor of Control and Robotics at the University of Naples. And also to move away from Star Wars, this weekend I actually saw a movie called Ex Machina. I don't know if you've ever seen it, but it shows sort of the development of robotics and artificial intelligence with human-like machines. And all I can say, it's definitely worthwhile watching and very intriguing in terms of the types of robots you get there. Bruno, the floor is yours.
Thank you. Good morning. I should say good afternoon, everybody. In this session is about innovative robotics and intelligent manufacturing, which is very much in the spirit of I4MS. So there will be 3 presentations, namely one by myself, and I'll give an introduction and overview of one of the 7 projects in the I4MS cluster, namely EUROC project. And then I'll leave the floor to Javier Garcia, who will be speaking about intelligent fixtures, and to Harold Breitbach, who will report an SME experience in the framework of the Interfix project. EUROC is one of the 7 IPs, which is coordinated under the I4MS Gate umbrella, and as you realize from the acronym, is a project about European robotics challenges. So according to the template that we've been given, I'll tell you what we have achieved, how we did it, how we received help from I4MS, and last but not least, how we will take it forward. Challenges are very popular in a number of domains, and robotics is whatsoever no exception. Since some of you might be aware of the grand challenges organized by DARPA in US, although this was like for military and defense application, we have a different way of carrying out research and likewise challenges in Europe. So our idea was to launch 3 industry-relevant challenges, and this was launched a year ago, in April 2014, and differently from previous project, as you might have read in the nice glossy brochure which was given, EUROC is also as a sort of follow-up project to another project which was run within FP7. I'm speaking about the ECOD project. ECHOD was the European clearinghouse for open robotics development, and it was sort of pioneer into the system of having the open call for experiments. And EUROC and other projects belonging to the I4MS cluster have benefited from the effort there. Differently from ECHOD, our idea here was to just basically like two new concepts. One is to get end users on board from the beginning into the experiments that the teams will be developing in this kind of challenging framework. And the other idea is very much in line with what Khalil Rouana was mentioning this morning, is the idea of the competence centers and the clusters. So as you can see in these pictures, we have three scenarios. In one word, those can be considered as a production scenario that, according to the robotics lingo, is the reconfigurable interactive manufacturing cell, human-robot cooperation, if you wish. The second scenario is about logistics, so it's a shop floor logistics and manipulation, or to speak the robotics language, this is mobile manipulation. And the third scenario, which is the most innovative one, especially in a kind of classical field like manufacturing, is the scenario of servicing. And the peculiarity here is that the use of aerial robotics technologies in plant inspection and servicing, because aerial robots are being used also for industrial application, not only for this kind of patrolling, surveillance, because the main idea is to have a flying hand besides having a flying. So in a way, you can achieve manipulation by using an aerial robot. So each of the challenges is divided into 3 stages of increasing complexity, and the project will end by December 2017 with 1 EUROC winner team. Although, of course, we can't use taxpayers' money to give a monetary prize like the Americans do. It's only for the glory, because basically what the teams will gain by participating to EUROC was financial support of the experiment in the second and the third stage, as I will describe in a minute. How we did it. As I stressed already, each challenge involves the whole manufacturing supply chains within the respective field, and this is also very much in the spirit of favoring technology transfer from academia to industry. We are in a stage in robotics that we've had 50 years of development of what we consider core methodologies and technologies. Now, there's been a lot of successful applications of robotics, but what we feel is missing within the robotics community, and this is very much the case for manufacturing, is the lack of standards, the lack of benchmarking. There have been many, many successful applications developed in the lab, taken to the exploitation phase and the pre-commercialization and so forth. But in a way, I think we need more standards and we need more benchmarking. So we launched the first stage of our challenge program. This was a simulation contest, and we had a number of applicants competing on a kind of virtual machine, solving 3 CHAMP scenarios for the 3 respective challenges. So after this phase, we move on, which is happening right now, to the stage 2, which we call realistic labs, in which the selected challengers from each team, the qualified teams, have teamed up with partners from industry, and they are ready to share the existing resources at the 3 top European platforms. I forgot to say, just going back for a minute to the 3 images here, is that the first platform is located at IPA Fraunhofer in Stuttgart, and this is very much also in the spirit of favoring a sort of liaison and synergy with a German initiative. I'm speaking about the Arena 2036, which is a huge initiative for robotics for manufacturing, and the lab available in Fraunhofer at IPA will be used for both, as a scenario for both Europe program and also for the Arena 2036 initiative in Germany. The second scenario is located at DLR in Oberpfaffenhofen. in the Center for Robotics and Mechatronics, which is part of the German Aerospace Agency. And the third platform is located at ETH in Zurich, which is another top institution in Europe and especially in robotics. So going back, this stage 2 will be developed in these realistic labs using the sheer existing resources. So differently, for instance, from the previous project like ACORD, is that all the teams will play, you know, the word play was used this morning, and this is very much the case. So we'll play because in the end it's a competition with the same toys, basically with the same sort of robots, with the same sort of platform, and this is very much needed for achieving benchmarking of different solutions and different algorithms. Then in the third stage, which we call the field test, those teams which will get the best performance on the realistic labs will have an opportunity and also a further funding to take their experiments to the field test by the, at the real use cases by the end users. And this will also allow to ensure sustainability and adaptability to the end users. And our most optimistic hope is that also for those teams which will not receive financial support to advance to the third stage, they might have an interest in continuing to team up with the end users and take the experiment to the field test with their own support. This is giving them a considerable amount of money and support in the second and third stage, because we have a 7 million grant money available to the challengers. So this is the chartboard in which you can hopefully see the 3 stages. This is the simulation contest, and we received more than 100 applications. At the end of this stage 1, the 15 teams with the highest score into the simulation contest advanced, and they team up with the end users. We had this huge event, which was a brokerage workshop held in London just before Christmas, and this attracted more than 100 end users. So at the end of the day, there were more end users willing to team up with challengers than we could accommodate with the 15 teams qualified per each challenge. So the proposals were submitted by February the 9th. Proposals have been evaluated, and now I can't reveal yet because it's still under approval with the European Commission, because the panel for selecting the best 15 best 15 experiments took place in Naples less than a month ago, and now we are in a stage of having all the paperwork approved. But I can anticipate that on June the 8th and the 9th will be done, because there will be a benchmarking workshop at the DLR in Germany, in which the 15 teams will be invited, and they will know the rules of the game in the stage 2. And as you can see, further to this financial support of 375,000 euro, which is quite nice for 15 months of activity, those 6 teams which will advance to the third stage will be able to receive an additional 210,000 euro financial support for another 9 months of work. How we received help from I4MS. Before doing this, I just want to recap what are the 4 classes of stakeholders that are involved into the Europe Play. Challengers, of course, and those are primarily academic or research team, but could also be individual, private persons willing to take place, and there were a few cases like that. Then we have end users, which are manufacturing companies, which can provide use cases for the challenge teams, but also we had a few technology developers. Those are either companies or research organizations developing innovative technologies and looking for an application of their technology in this industrial robotics domain. And last but not least, but only for Challenge 1, which was the most open, system integrators. So companies that specialize in either bringing together robotic components and subsystems or developing and commissioning the whole robotic systems. So there was a huge campaign for promotion of the Challenge program, and I4MS was very useful, especially in those public events in the Info Days. We had the regular presentations from I4MS in the Info Days, and we held several Info Days. One initially for the academic research community, and there were like 2 other Info Days and a lot of regional events to inform and to spread out the news about this funding opportunity for the companies, and especially for the SMEs. And also, we had a regular distribution and dissemination through the I4MS website and also the newsletter, and also we organized, thanks to I4MS Gate and Sylvia especially, 3 webinars in which we were entertaining the potential people interested. How we will take it forward from the last 2 minutes of my time slot. So this is the statistics of the call. As you can see, we received, those in purple are the challengers, it's more than 100 as I said. Those in blue are the technology developers, those in orange are the end users, and those in gray are the system integrators. So we had many proposals submitted. What is of interest to this audience, of course, is SMEs. So those are the figures for the 3 categories, for the end users, the system integrators, technology developers, of those companies that are SME. At the end of the day, I cannot give the names yet because those have not been officially approved, but we know that most likely admitted to stage 2, there will be 7 SMEs. 3 as end users for challenge 1, 4 as end users to challenge 1, and 3 as end users to challenge 3. And as we were discussing into the midterm event a month ago in Brussels, I mean, this is quite interesting. It's a lesson learned. In a way, there were more interests from SMEs regarding the traditional scenario of production, like a manufacturing, or the really innovative one, like aerorobotics. So a lesson that we learned is the one in between, like logistics was of less interest, at least to the SME community. So this is a lesson that we have learned. And in my last slide, I'm just anticipating the topics of the 7 experiments that will feature SMEs. In challenge 1, we have one on cooperative, safe, and reconfigurable robotic companions for CNC pallets, load and load stations, so you can get an idea of what will happen in the next 15 months. The experiments are expected to start between July and August. Intelligent and safe robotic co-workers for automotive assembly and operations, and this was one of the issues also in common with the previous presentations this morning. Robotized coils winding for electric machine manufacturing industry. Reconfigurable assembly cell for highly dexterous and intelligent operations. And finally, concerning challenge 3, we have an autonomous multi-aerial vehicle-based inspection system for large structures, inside-outside chimney and smoke pipe inspection via aerial robots, and a visual inspection system for wind turbines via teleoperated multi-aerial vehicles. Thanks very much indeed. I can be reached at this coordinate. I very much regret that I have a flight to catch at 3, so I am taking off straight ahead, and I apologize also with the 2 speakers in this session, but you can catch back with me at my email address. Thanks.
Thank you, Bruno. Immediately proceeding, now ask Javier Garcia to come up to talk about, he's the programs coordinator at IK for Techniker, and yes, floor is yours.
Thank you, Mr. Chairman. Well, I'm going to talk about Intefix, which is a project regarding intelligent manufacturing. And into manufacturing, it deals with the problem of fixturing, which probably you know is one of the main problems to be faced in order to increase safety and accuracy during relatively conventional machining. A very brief overview about what Intefix is in this slide. You see that we already had around 2/3 of the whole project. We started in July the 13th. And the partnership is quite wide, 32 partners, 19 of them SMEs. So we have a huge SMEs participation, which is in good fit with the purpose of the I4MS initiative. Well, the main objective, the main key issue of the project is to deal with the problem of fixturing. increasing security, safety, and improving accuracy. The idea is to move from conventional fixturing elements to intelligent ones. That means that the fixture becomes a CPS. We are talking about, of course, actuators, sensors, and what we have implied is mechatronic systems, issues regarding adaptability, modularity, and flexibility. And we have a philosophy of moving upwards through monitoring and moving downwards through actuation. The idea is to develop some design methodologies for fixtures that integrate software tools, CAH family, and also simulation tools or algorithms developments, jointly with some developments in the field of hardware. The philosophy is integrating technologies that already developed at the present state of the art. The structure of the project obeys to three main problems covered, and around these three main problems we built three working groups different, around vibration, around deformation, and around positioning. The project has 11 case studies, 11 experiments, 8 of them developed into the frame of the core of the partnership, and another 3 because of an open call with new partners. You see again that the number of SMEs in the different experiments is very important. Talking now about what we achieved, I'm going to talk only about 3 case studies, 3 experiments that the results are, let's say, almost for sale. We have, I remember you, 11, and the rest are under development. The first one refers to the turning of low-pressure turbine casing with the purpose of reduction of vibration and increasing performance with tougher cutting conditions. The expected improvement is quite relevant. We are talking about 10% increase in the tool life and 30% in productivity. The main protagonists in these particular experiments are Fedrac Technologies and Wolfel. By the way, Wolfel, we have afterwards an intervention explaining their activity. The element developed you have in the slide, and we expected a commercial cost around 2,000, 3,000 euros. Second case study almost developed is that regarding the distortion in aeronautical structural parts. You know that the aspect ratio in many aeronautical structural parts is quite big, and that gives serious problems in machining because of deformation. You see that the expected improvement is quite dramatic because we reduce the number of machining steps from 7 to 4, and also the number of the setups are dramatically reduced, as well as the machining time. You see here an example of a completely deformed piece, another one as a result of the new improvements. Third case study is fixture system for workpiece adjustment and clamping with or without spread deformation. We are talking about, in this case, of location of the workpiece. You see that we combine some metrology software with algorithms to obtain the target position, as well as the development of particular hardware. One of them will be the main issue of the next presentation. And the improvements are regarding positioning accuracy and reducing the deformation. Talking wider about the whole experiments, you see here in this slide all the pieces that all the case study will deal with. We are talking about normally big pieces with some problem of rigidity. It's the common problem for all the cases. The partnership is organized depending on the specialization of each of the members in 4 main groups of specialists around sensors, around actuators, around fixtures, and around end users. You see here all information. The main focus of all the developments is to pursue actual new products combining some software development with particular hardware.
1 minute, Javier.
1 minute? Okay, thank you very much. Of course, that the belonging to I4MS, it has been an important advantage because it offers very important support, mainly to obtain soundness and to receive some attention from people through the open call. It also strengthens the collaboration between other possible I4MS projects, and it's also a service for the competence centers implied in the proposal. How we will take it forward? Sorry for the mistake in the slide. Well, the idea now is that products that had been already developed will go into the commercialization phase, and for that we are thinking of some particular sectors, such as aeronautics, precision engineering, machine tools, etc. And there is some commercial networks belonging to the members of the consortium that will be used for doing that. I think that's all. Thank you very much.
Thank you very much. Final one before lunch, Harold Breitbach from the Willful Group, who's going to talk about the SME experience. And before lunch, we only have room for probably about 2 urgent questions, so if you've got ones, let us know, and otherwise lunch is waiting.
Thank you very much for the introduction. My name is Harald Breitbach. I'm working for the Willful Group, and we solve vibration and acoustic problems in general. For the details, you can look on our homepage. So I understand my presentation as a supplemental to Javier's presentation he just gave. And yes, and thank you for the clock. So that's good. I think I will catch up some time because my presentation will be rather short. And I try to make it very clear. And I won't talk about software, just about the very special problem within the Interfix project we have. So as Javier already mentioned, one problem is the vibration between the
or caused by the interaction between the workpiece and the tool. And that has a big impact on the economics in the production. So, you can choose between a poor quality of the workpiece when you mill very fast, or it takes very long and you have a good quality. But the two things together up to now is not possible because you have vibrations that cause quality disadvantages on the surface. So our main goal is actually to double the accuracy of the workpiece in the milling process and minimize the lead time, of course, with that, and at the same time to improve the surface quality. For that purpose, we are right now developing a device, a so-called active vibration reducer. And the idea is that you attach it directly to the workpiece and to avoid the vibrations caused by the interaction between the tool and the workpiece. It has an integrated sensor and actuator device, and it can significantly reduce the vibrations so that at the end you can get rid of the previously discussed problems. Afterwards, for all of you to wake up before lunch, I will show you a short movie showing the function of this device here on the table. But that's just when I'm finishing the presentation. So you have, by attaching the device to the workpiece, you have, as I said, you have everything integrated in this device. It's the sensor that is sensing the disturbance, then a controller, which is could be any kind of control algorithm, so it's not fixed up to now. It can be analog or digital. That really doesn't matter. At the end, it has to work. Then we have an amplifier, and this amplifier is driving the actuator in a way that interferes with the disturbing vibration. That at the end you have a smooth tooling process. So you see a picture. You already saw it in the previous presentation of Javier. This is the device that we will test in the test bed that is already prepared. And we are very sure that this will absolutely work. So I leave it to the presentation of Javier to show or to explain how I4MS helped us. For us, it's absolutely the possibility to make our products or give us the opportunity to network and to show everybody what we are capable of doing, and that is the main point. And how we will take it within the project of Interfix, of course, I understand us or Wölfel as a small part of the network or of the Interfix project. Our chance is to contribute to the operating and economic efficiency in the tooling process throughout the industry. And you named one example in the aircraft industry. For example, if you are tooling the surface of CFRP structures, which are very light, then you have always the problem that you have vibrations. And this is only one example, so there are many, many other examples. And contribute to establishment of commercial network within the EU. So production engineering in general, workpiece fixtures, machining tools, and precision engineering. And of course, to create business and find partners to which we can work together with. So thank you very much. Hopefully I can find the directory where the movie is. There's no sound, unfortunately. Actually, this table is exciting noise and making noise, which we cannot hear, unfortunately. And if we switch the device on, the noise will go away. Thank you very much. That was very helpful.
Noise.
Yeah, absolutely. So imagine the table is being excited by another device, which is not seen in this movie here. You put this device on the table, switch it on, and it will adapt to the vibration that is disturbing and automatically get rid of the vibration by 20 dBs or something. Okay, thank you very much for your attention.
Sorry, the first thing that comes into my mind when I see this vibration reduction machine is I wonder if they have a version for children, you know? If you can turn it on and the children become quiet. But anyway, thank you very much for that. Briefly, one or two questions either on the laser presentations or on the robotics presentations, or ones that we've had this morning from the audience that you would like to ask before lunch. Put up your hand if you do. Otherwise, I know that your tummies are having the majority of your mindset at the moment. Any comments or questions that you cannot handle during lunch? Okay, then I suggest we go to lunch immediately. Let's take about 45 minutes lunch, so get back here about 2:05. Thank you very much.